Hello everyone, in this video we'll see a competitive programming problem called rat in a maze. Let me just explain this problem. This is a famous backtracking problem. Here you can see one grid. This is the maze, and in the top left corner one rat is there, and in this maze the rat can travel left, right, top or bottom. So it will travel in this maze and it will finally reach the cheese in bottom right corner. Actually, we want to print whether this rat can reach this cheese, whether the rat can eat this or die. Okay, now we have to interpret this problem to a matrix format, literally zeros and ones. So 1 stands for there is an empty space, and 0 stands for there is a blocking. So here you can see in this way we can reach. Always this first cell, the top corner cell will be 1, and this bottom left corner cell will be 1. So there will be a rat also and there will be a cheese also. So that's what here it's represented as a green cell as 1 and this black cells as 0. So the map here, you can, this rat will go this right direction or down direction, or when you consider this cell, it can go up, it can go this left direction, it can go this bottom direction, and this can go this here it is blocking, it can't go, but it's possible to go when it is 1. So we want to find out that whether it can reach. If it is reaches, you have to print 1. If it not reaches, you have to print 0. That's what the whole problem is. Okay, now I am just clearing this. So okay, the algorithm is backtracking algorithm we are using. So let me bring this matrix. I'm moving this one to here. Okay, now the algorithm is here. We will be standing, so we need a separate algorithm. So what I do is I move back and I'll just type the prerequisite of getting the user input. I'll type from hash define and row as 100 and hash define column as 100. And here I need a row and column, so I'll type RNC, and I need an array, so I'll type int arr. Here I'll make it as row and here column, and I'll output as enter RNC. I'll receive it in R and C variables, and then I enter a for loop int I for R, and one more for loop for int j and c. Inside of it, c in arr of I and j. Okay, now we just received it, and we need a function here. This one you can keep it as backtracking problem also, and you can keep it for the DFS also. That's totally fine, but the logic is literally same. Here I'm printing int x equals DFS of we need an array reference, and I told you that we'll always start from the top this corner, so it will be 0, 0. So I'm giving as 0, 0, and we need total number of rows and total number of columns, this. And if this x equal to 1, cout, we can print eat indel, and else cout die indel. I'm just formatting this document. Okay, now we need to write this function. So what I need to do is I'll write int DFS. I need this array reference, so int AR of, I can write here row and column, and current row and current column I'm giving it an RR, and I'm giving total row as capital R and total row column as capital C. So now here I make this R means current row, and small c means current column, and capital R means total rows, and capital C means total columns. Okay, now we have to write our function, our logic to solve this. So line by line I'll interpret. So far we have just received the user input. So far we have written the codes like we're getting the user R and C, and we are fetching those variables and calling function, and here if it is 1 it will eat or else it will die. Okay, now first we need this is a recursive function. DFS always a recursive function, so we need to write a condition like when it can enter into the function. So this entering conditions, or you can name it as limiting conditions. So okay, here what is the limit actually? The rat is here, so it can't go beyond this wall, or here, or it can go below this wall, or here it will revolve, run around in this maze itself, so it can't go outside. So how do we detect that it will go outside or not? If it is we are getting a number which is greater than this total column count or total row count, we should not proceed further, we should not move in those directions. So we have to limit that. And if it is less than 0 also, it is not possible. Here you can make an assumption that here it starts from 0 and n-1 it ends, so it will not go below 0. That means -1 is not possible. So we need those conditions so that the rat will not come out of this maze. So how do we write that? Is if R less than 0 or C less than 0 or R greater than or equal to capital R or C greater than or equal to capital C. Here this equals to is 1 because we are starting from 0 and it is -1 it comes, so I'm giving this one. And then if it is blocking wall, we can't move in that wall, so I'm giving RR of equal to 0, so we can't go. Here is written 0, here R and here C. I hope you understood this one. because recursive function, somehow we have to limit that function. So that's the reason we are returning 0. So it should not proceed further. So here, if it is not at all there, anything is there, it will go out. So when we are reaching the target, we don't need any calculations. For example, here I reached this place, so again I no need to proceed further. So once I reached here, I should return as a success message, that means 1, so that I will not provide any calculation further. So what I'm doing is r equal to r minus 1, that means the last row, and c equal to capital C minus 1, and that should have a target, so equal to 1, R and C. In such case, I can return there is a success, which successes we literally denote it by 1, so I'm returning 1. And then once I visited one cells, there is no need of visiting it multiple times, so I make it as RR of equal to 0. Even though that is 1 or 0, I no need to visit that same again and again. R and C, so that's assigned to 0. Okay, now the actual conditions, it should travel all 4 different directions. It should go left, right, top or bottom. Top condition you can't go, because here if it goes to the top, it will returns and comes as 0. It will go left and returns comes as 0. So here it goes right, it will successfully, it can go and proceed further. Down also it's possible to go and proceed further. So there is 2 conditions, but you have to travel all the directions. So how do we, this cell we can keep it as a reference. Here how do I write is rat plus 1. Here this rat, what it's standing is, I'll just increase this font. Here this is literally the rat where it's standing, it's plus 1, which means the column all here rat's column plus 1. Here the row is increasing, so row plus 1. When it is here, you can mention this as row minus 1, and here column minus 1. There are all 4 different directions will be covered. So above the row is here, this is the row, and you are going the previous row, which is nothing but row minus 1, and here you are coming the previous row, column, so column minus 1. When it is here in this condition, you are making the next column, so column plus 1, and when it is here we want to come down, it is row plus 1, it means the next row. So I need to travel all 4 rows. Wherever it finds that in the recursion, it should return true. So I'm writing the same DFS, I'm passing the array reference, and R, I'm going the previous and same, and the capital R, capital C. If it comes as 1, I'll return 1. The same condition is for all 4 directions, so I'm copying the same, but here the value will differ. Here plus 1, here this is the above row, so above row is like upper side traveling. Then this is like literally left side traveling, right side traveling. And this is left side traveling. And this is downwards traveling. This is up, right, left and down. but even though if you mix it, like if you change this order also, that's not a problem. It will successfully, it can run. So that case you can run all this, but you can combine this all statement and run this. If there's none of this case is there, you can just return as 0. Okay. Okay, we'll just execute and we'll check this. Okay, now I'm running this code, run, and I have some test data, this, so I'm copying this. Here you can see this, there is a way in this one, so it should eat, so the result should come as eat. So I'm copying and pasting here, so it is printed. So I need one more test data. Here also you can see this, there is a spiral kind of one path is there, so I'm copying this and running the same code. It should eat. For a negative case, I'll block this one as 0, so that there is no way to reach this target, and I'm running this same. It should print as die, so it is printing as die. Hope you understood this conditions of traveling this left side, right side. So there is a concern of why this DFS or this same recursive function is there. So recursive functions you have to use when you have repetitive tasks to solve a subset of problem. Here, once this rat is here, you are going to same, there is a upside downside traveling, and when it here also you are going upside downside right left, those kind of repetitive task will come. So here also when it is wherever it is, you are calculating that function as same functions. So that's the reason you are going here with recursions, and you can simplify this problem as you can include this OR condition here itself. It should give the same answer. You can write it as one line. This is literally same. You can because anyhow you have to reach that. That's it. Whether you are upside traveling or downside, that's not at all a concern. Whether you are reaching that target or not, that's the result. You can still run that. It will print die, and if it is changed to this as 1, copy, run the code, and it will eat. Okay, this is limiting condition and this is the success condition. And this is, I explained that why I have given, because you need no need to once we have rat here, again if in case, because all directions that function will trigger, so it will not go to again back to this row itself. So we are marked as 0, we don't need to go at all. So that's the reason it's made as 0 here in this line number 18, and you're from that you're traveling in all 4 directions. And if you find out anywhere in the problem that you have success condition, then you're returning it as 1, and then based on that condition we'll eat or die. That's getting printed and we'll run the output. Hope you understood this problem and the solution using DFS. The backtracking algorithm also is similar and literally same. You will maintain one more array called visitor array. That's all not required. In this case, you can just write it in the array itself. Okay, thank you for watching, and we'll meet in the next video.